Hello, welcome to this channel. My name is Enoch. Today we will continue our series on networking, and we'll be looking at classful networking and classless inter-domain routing. We will look at subnetting, and we will also look at fixed length subnet masking and variable length subnet masking. We will look at route summarization, and we will also look at IPv6. And let's get right to it. Classful networking, in my last video we discussed about the various classes of IPv4 addresses that we have. We know that class A IP address has a subnet mask of /8 and has about 16.7 million hosts per network, and we know that class B IP address uses a subnet mask of /16 and has about 65,536 hosts per network. And we also know that class C IP address uses /24 subnet mask by default, and it has 256 hosts per network. And classful networking is just a situation where we are using the fixed subnet mask, in our network. You are using, for your class A, you're using your /8. For your class B, you are using your /16. For your class C, you are using your /6024. Imagine a situation where you have an organization that has about 50 IP address and need about 50 IP addresses, and they are using this class C, even class C IP address. They will still be having about 204 IP address or 206 IP address that are not used. So classful networking has a drawback in that it results in a lot of wastage of IP addresses, unused IP addresses. And that brings us to classless inter-domain routing, which gives us an opportunity to have varying sizes of subnets. You can have /10, you can have /20, you can have /24, you can have you can have as small as you want, you can have as big as you need. So it does not rely on the default, predefined classes or subnet mask, but instead it can have flexible network sizes determined by the CIDR notation. So it reduces IP wastage by providing only the necessary number of IPs, to each network, and it allows for route summarization, which results in routing efficiency by combining multiple networks, into a single entry. And subnet masks are often represented in CIDRs in classless inter-domain routing. If you have a situation where you have 255.255.255.0, you know that the binary of this subnet mask is 1111, one like this, and where this one ends, that's the number of bits that you'll be using from the beginning to where the one ends. That's the end of the bit that you are using for that network. So that gives you 8 plus 8 plus 8. So this can also be written as /24, /24. So the remaining part, which has this 00, it will be used for the host portion, and this will give us 8 bit for the host portion, 24 bit for the network. So that's that. So you can also write it as /24 like this. Write the IP address, write /24. This means that the first 24 bit is used for the network, and the remaining 8 bit will be used for the host. That's what it means. Let's move on. So let's assume you also have 255.0.0.0 as your subnet mask, and the binary representation is this, and where this one ends, that's where the network portion ends, and this is 8 bit. This is 8 bit, so that means you can write it as /8. So that's 10.10.10.15/8. We know that the first 8 bit will be used for the network, the remaining 24 bit will be used for the host. So that's that. Let's move on. And you know that if you are using /8 for the network, just subtract 8 from 32 because IPv4 address is a 32-bit IP address, and just subtract 8 from the IP address from 32, and you have 24-bit left for the host. If your subnet mask is /24, subtract 24 from 32, then the remaining 8 bits. Just subtract your network size or your CIDR notation from 32, and the remaining bit is what will be used for the host portion. Now, subnetting, if using default subnet mask usually result in a lot of wastage, and that brings us to subnetting. Subnetting is a situation where you can break a bigger network down into smaller subnets or subnetwork as the need arise. You need /10, you need /20, you need /25, you need /26 or /30, whatever size of IP address you need. You need 20, you need 30, you need 40, you need 50, whatever size you need, you break it down, and get your subnet size. So it is a process in networking that involves dividing a larger network into a smaller, more manageable subnet, or subnetwork. And it's done to improve network performance, to enhance security. When you are able to isolate any subnet that you want, you are able to isolate any subnet that you want, and that can improve security a lot. And it also helps in making efficient use of IP address, because an IP address will not be unused much. So that's that. And the way subnet is done is by borrowing bits from the network portion, from the host portion, and adding it to the network portion. Bits are borrowed from the host portion of the IP address to create additional subnetwork. So if you borrow 2 bits from the host portion, you can create 4 subnets. Let's look at subnet calculation. Now, if you borrow n number of bits from a particular network, the number of subnets that you can create will be 2 raised to power n. So if you borrow 2 bits from the host portion to add to the network portion, the number of subnets you can create will be 2 raised to power 2, which will give you 4. That means you can create 4 subnets. Same size of subnet. If you borrow 3 bits, if you borrow 5 bits, 2 raised to power 5 gives you 32. That means you can create 32 subnets. That's just that. So the remaining portion of the IP address will be used for the host. So just subtract your subnet mask bit from 32, and the remaining portion will be for the host. Let's look at an example. This is a Class C IP address, 192.168.1.0, with a default subnet mask of 255.255.255.0 or /24, and we want to create 4 subnets from this. So what do? We borrow 2 bits from the network portion. This is the binary representation of this IP address. Let me just write it and you can see. So this is 255.255.255.0. This is the binary representation. This is the binary representation. This is the binary representation of the subnet mask, and we are this is 24, 8, 8, 8, add together 24. Now we want to create 4 subnets. So we borrow 2 bits from this host portion. If you borrow 2 bits from this, if you borrow 2 bits, let's borrow 2 bits. If we borrow 2 bits, this one would become 1 1 1 1 1. So if this becomes 1 1, then 2 raised to power 2 will give us 4, so we can create 4 subnets from this. And the remaining host that is left, the remaining bit that is left for the host portion is 6 bits. We have borrowed 2 bits. So now what will be your subnet mask in decimal? Convert this into decimal and you have your number, so 255.255.255. Now the 4th octet, what is the decimal of this? 128 plus 64. That will give you 192. So is the default, the new subnet mask now is 255.255.255.192. Now, if you don't understand how I get this 192, please try and watch my first video on networking. I will put the link below, and you will understand how I get 192. Just convert this to decimal, and you will get 192. So this is the subnet mask, and the CIDR is /26. So we have 6 bits remaining for the host portion, and 2 raised to power 6 will give us 64. That means each of the subnets we have 64 IP addresses. So they will increase by 64. Each of the subnets we have 64 IP addresses. So the first one is 192.168.1.63. It will end at 63. 0 to 63 is 64, right? So it will end at 63. So this is the first subnet. Add 64 to it, you get 127. What's the first IP address? They add 1 to this, you get 64. So it will range from this to 127. That's the second one. So the third one, add 64 to this, you get 191. Add 1 to this, you get 120. That's the starting point, and so on and so forth like that. You get 255, you get 192. Don't forget, you are going to remove in each of the subnets, you have to remove the first IP address for your network address, and you have to remove the last IP address for your broadcast address, and the usable IP address will be the remaining IP address. For this first subnet, it will be 192.168.1.1 to 192.168.1.62. all right, do the same for the rest and you'll be fine. So let's move on. Let's look at another example of subnetting. We are subnetting a class B network. Let's 172.16.0.0. The CIDR is /16, and we know that you can create 65,536 IP addresses from each of the network, from this network, and we want to create 4 subnet out of it. So we borrow 2 bits. This is the binary representation. Sorry, let me change this to 0 so that you won't get confused. 0, and let's bring it back. So this is the binary representation of this subnet mask 255.255.0.0, and this is the binary representation, and we want to borrow 2 bits from the host portion. If you borrow 2 bits from the host portion, then in the 3rd octet you borrow 2 bits, you have 1 1. So now you have your 16 plus 2, which give you 18. So your subnet, your new subnet, each of the subnet will now be /18. We want to create we'll be able to create 4 subnets from this. And what do we do now? Let's get each of the subnets. So the remaining bit for the host in this 3rd octet is 6. We have 6. So this third octet will increase by 2 raised to power 6, which is 64. So this third octet will increase by 64 in each subnet. And let's just go and look at it like that. For the first subnet, we have 172.16.0.0. Of course, that's the first IP address, and we know that it will increase by 64. So 263 is 64. And for this last octet, you are looking at it. How did I get this 255? For you to get your broadcast address, just turn the last octet into 1111111. Turn everything into 1, and you get your 255. That is the last IP address in this subnet range. So that gives you that. For the next one, add 64 to 63, you get 127. The same thing applies to the 255. The last IP address, the broadcast address, will be, everything. The last octet, change it to 11111, everything 1, and you get to your 255. And do the same. Add 64, you get 191. And you get your first IP address here. This one 64, 0.0. Of course, that's the next IP address. For this one, it's 128.0. For this one, is 192.0. This is the range for each. Don't forget, the first IP address in each range will be for the network address, and the last IP address will be for the broadcast address, and the remaining IP address range will be the usable IP address for each range. So that's that. I hope you understand. Let's move on. And now, variable length subnet masking is just a situation where you have varying sizes of subnet. That's just what it means. You don't have a fixed size. The subnet that we have been doing the same size of subnet. We have been doing same size of subnet, and now we want to look at how to varying length subnet masking. That's what this is all about. It allows subnet masks to vary in length based on the network need. Some department in your organization may need just 10 IP address, some may need just 20, some may need 50. You have to be able to break them down into varying sizes and use them accordingly. So let's look at an example of it. So let's assume you have this particular IP address. You have a department that needs 50 IP address. 50 IP address. All right. How many hosts? That's what you first need to know. In this varying length, you need to look at how many hosts do you need. How many bits? How many bits do you need to create 50 IP addresses? 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, 2 raised to power 5 is 32, 2 raised to power 6 is 64. 5 is 32. That's not enough for our 50 IP addresses. So the next one is 2 raised to power 6, which is 64. So we need 6 bits to get 50 IP address. So if you remove 6 from 32, that will give you 26. So our CIDR will become /26. So /26, that's it. So 10.1.0.0. The remaining proportion for the host is the remaining bit for the host. The remaining bit is 6. So if you 2 raised to power 6 is 64. So it will be from 0 to 63. All right. Now we have another department that need 20 IP addresses. How many bits do we need to create? How many bits do we need for the host portion to create 20 IP addresses? We need 5, right? We need 5. 2 raised to power 4 is 16. That's not enough. So we need 5. 2 raised to power 5 is 32. So we need 5. If you remove 5 from 32, you have 27. So our CIDR becomes /27. The next IP address here will be 0.64. So this one starts from 0.64/27. And the remaining host we end at where 2 raised to power 5 is 32. Add 32 to 63, that gives you 95. So this IP address range we end at 95, 0.64 to 95. All right, we have another department that need 10 IP addresses. Okay, how many bits do we need for the host portion to get 10 IP addresses? 2 raised to power 3 is 8. That's not enough. So 2 raised to power 4 is 16. That will be enough. So we need 4 bits to get 10 IP addresses. Remove 4 from 32, we have 28. So your CIDR will be /28. Now for your host portion, 2 raised to power 4 will give you 16. So add 16 to 95, you get your 111. So the range of this IP address will end at 111, and the starting point will start at 96. So that's just it. So you can do this exercise for your subnet. Just do fixed sizes and just do /10 just for practice sake, just do it. Fixed length subnet masking. If you have any problem, if you have any issue getting this solved, just let me know in the comment section. I will treat it another day. All right. Fixed length subnet masking is just a situation that we have seen here, where we are doing example of subnetting, and we created four subnets out of this particular /16. So we can only create the same size of subnet. Each one we have 64 IP addresses. Each one we have 2 raised to power 14 IP, 2 raised to power 14. Each one we have 16,384 IP addresses. So is a situation. So fixed length subnet masking is a situation where you have the same size of subnet. Is a technique in IP networking where each subnet within a network is assigned an identical subnet mask, and this results in subnets that have the same number of hosts per subnet. So let's look at an example of it. We have seen the example earlier, so maybe we can just skip the example. Just go and see the example I gave earlier on subnetting. The 2 examples, the same thing. They get fixed length subnet. They use fixed length subnet masking. So let's move on. I just want to give you this /31 as example because it breaks the standard rule of IP addressing by not having enough host IP addresses to remove the network address and the broadcast address. /31 will give you only 1 bit left for the host portion. 2 raised to power 1 is 2. That means you can only get 2 IP addresses for each subnet, and you will not be able to remove your network address and your subnet mask. So that means that you can only use it for point-to-point link. Just note, you can only use it for point-to-point link. So anytime you need 2 IP addresses and /31 is not specifically requested for, just use your /30. /30 give you 2 bits left for the host portion, and you can easily remove your network portion and your broadcast address out of it. So this will give you 4, and you can remove the network address and the broadcast address easily, and you get your remaining 2 IP address in each subnet. So let's move on. Route summarization is also called supernetting. It is the opposite of subnetting. It's a situation where we combine multiple subnets into a larger network. It combines multiple smaller networks into a single larger network to simplify routing. It reduces the size of routing tables by aggregating multiple subnets into a single route entry. And let's look at an example. We have this network. We have these networks, and we want to summarize it into a single network. How do we do it? All right. First, we are lucky they all have the same subnet mask, so this will be easy. So let's look at the common previous in each binary representation. So the binary representation of this for our network is this. So the first thing you need to look at is identify the common prefix there. What is common in this IP address, and what is common in this binary representation. And if you look at it, your common point there is here. Common point is here. That's your common point. So so this is your common point. This is your common prefix. This is your common prefix. So that's where we are going to break it. So we have 6 bits that you can use as part of in this third octet, that you can use as part of your network address. As part of your network portion. And 6 plus 16. This is 16. And if you add 6 to it, that gives you /22. That gives you /22. So we'll now create a bigger subnet of /22. So what will be our network address and our subnet mask? What will be our network address and our broadcast address? All right. So of course, if you look at it, if you convert this /22 into decimal, this is what you will get. For this, if you are looking at, if you are thinking, oh, how did we get 252? Just assuming this is 11111 and this part is a 0, what will this give you? This is what I'm saying. Let me first bring it down and let me edit this. Let's say this is 00, and the remaining 6 are 111111. All right, now let's look at it. This third octet here, if you calculate this binary, what will it give you? What will it give you? You know, we are using the first 6 bits. If you calculate this binary, you will see that it will give you 252. You know, because we are using the first 6 bits, it will give you 252. You know, you're surprised. So that's that. That's that. All right. So let's move on. Now, we have gotten how we have seen how I got this 252. Now let's look at our network address. What will be our network address? Of course, our network address will be the first IP address in the range, and which will be what? It will be 192.168.0.0. That's going to be your first IP address in the range, and it will be /22. You know, and how we got it is this. You know, this is the first possible, and everything will be 000. You know, then. So now, how do we get our broadcast address? Now let's look at the last possible IP address in this range. Now that means you are going to change this to 111. This portion, change this portion to 211. That gives you 255, and this portion too, you will. That means this portion too. You have your 11 there like that. This portion. So this is the way it is. So you find the binary of this. If you find the binary of this third octet, it will give you 3. You know, it will give you 3. This will give you 3. If you find the binary of this, it will give you 3. So it will range from 192.168.0.0 to 192.168.3.255. That's what will be our range, 0.3.255. You know, so that's that. Let's check another example, and I want you to pause the video at this point and try this out. Try and see if you can summarize this IP address into one larger network. See if you can summarize this subnet into one larger network, and try it. Find your Supernet mask. Find your Supernet mask. Subnet mask should not be here. This is Supernet mask. This is Supernet mask. So find your Supernet mask, find your network address, find your broadcast address, and find a usable IP address range. So pause the video and do that now. So now let's continue with the solution. So let's find the common previous here. Let's change everything here into binary and find the common previous. So if you look at it, the common previous is at the fifth bit in the third octet, in the second octet, You know, let me just let me separate it so that you can see it easily. Okay, so let's look at this like this. So this is the common previous there. This is a common previous. So let's add this bit to this bit. So we have 1, 2, 3, 4, 5. 5 plus 8 gives us 13. So our Supernet mask will be /13. So let's find our first our network address. Let's find our network address. Our network address, of course, will be this. If you find this, it will be 10.10.0.0/13. That will be our network address. Now, as this is the common previous, and this one is there, so all these parts will be 0. This part will be 0. And if you find it's just like this. It's just like you turn all these ones to 0, move them together. That will give you your first IP address in this range. And if you find the binary, if you find the decimal of this will give you 8. This is 1, 2, 4, and 8. This will give you 8. So this is 10.8.0.0. All right. So that's your network address, and it will be 10.8.0.0/13, and your broadcast address will be turn everything to 1 from here. Everything like this to 1. So it will be 255. The last octet will be 255. And if this one becomes 13, if this one becomes 111, you know, if this one becomes 111, find the decimal of that, and you find the decimal of this and of this. This is 1 plus 2 plus 4 plus 8. That's give you 15. That will give you 15. So you have 10.15.0.0. That will give you your broadcast address. All right, let's look at it. So your Supernet network address is 10.8.0.0, you see, and your broadcast address will be 10.15. You know, just change everything to 111 and you get your, so the range in between will be your usable IP address. So which will be 10.8.0.1 to 10.15.255.254. I hope you understand it reasonably. All right, let's move on. Now, IPv6, I will just skim through IPv6 because IPv6 has not been fully embraced, you know, in the market today. You know, I'm not saying it has not been used; it's been used, but many people many organizations that are using IPv4 that I expected that they will have changed to IPv6 today have not changed. You know, changing from IPv4 to IPv6 has not been seamless for many organizations. And many network engineers are more used to IPv4 than IPv6. So what our organizations are doing is to combine private IP address with public IP address and using NAT, you know, in between. So That's the way they have been doing it. And but I just want you to know that IPv6 is a 128-bit IP address, and it was created after it was discovered that IPv4 address was not going to be enough in the 1980s, and it allows for 2 raised to power 128 unique IP addresses, which is astronomically large number. And so that's just that about IPv6. I will stop here for today, and thank you for watching. I hope you understand what we have done. If you don't understand, watch the video again and again, and I believe you will understand. So thank you for watching, and I will see you in the next video.